for inviting me. I love this event. I see some familiar faces. So I wasn't really given a topic to talk about. I think it was just assumed I was going to talk about robots. So I think what I was like, well, what do I, 20 minutes isn't enough. So I think I wanted to talk about there's like a crisis of a lack of imagination, I think, in construction robots right now. I've had a lot of situations lately where I'm in front of like large general contractors and I'm like, we will build you any robot of your wildest dreams. What is a problem that is solved by a robot and what should we be working on? And they don't know, and I find that odd, so I wanted to kind of talk about that a little bit. But I wasn't sure what to call it, so I was like, do I want to do like a Louis Kahn thing, where it's like, the brick wants to be an arch, or if you're Philippe, the brick can be anything as long as it's thin. I'm sorry I missed your talk, I was looking forward to that. And so I kind of was like, I want to work with the tension of narratives we have around these things, like around machines and our ideas about them, and machines kind of as a means to an end in themselves, just as something imaginative by human culture, versus other practical concerns, like what is a particular type of machine good for? What is a business problem that has ROI? The black on dark blue with the glare was a poor choice, that's right. So I wanted to start a little bit with like how we storytell about robots. And I think a lot of times robots are kind of a stand-in for things we fear in other people. So you've got like Maria as a stand-in for class tension. You've got Gog as a stand-in for the kind of enemy or the spy. Has anyone seen Gog, by the way? It is like the best robotics movie and no one has seen it. Really interesting commentary on like, there's like drones and radio waves and it's ahead of its time. THX, we're talking about authoritarianism and fear of power, and then obviously Terminator, which is kind of fear of our own technology. They're monster movies, they're just machines instead of monsters, and they kind of show our anxieties. There's been a little bit of an interesting kind of, I guess vaguely post-human kind of trend, I think, lately. I think Ex Machina, I think Ava is kind of like attributing personhood to a robot and then, being punished for that kind of misconception. Ava is just a machine and doesn't care about people, spoiler. After, you've had almost 10 years to see it. And you've got After Yang's another one that I don't think a lot of people have seen. It's a very quiet film, but I think it's one of the better ones I've seen lately, about an android that kind of has developed its own private romance, right? It has its own desires, its own ambitions. More recently with Alfie and the Creator, which is kind of like a messiah character for like an AI robot species, which is weird to have a messiah character because the robots are Buddhist. I guess it's weird for robots to have religion at all. But I think what all of this kind of does that is perhaps a disservice to robots, particularly the robots that lend themselves to the types of things we care about as practitioners in construction, is that it's about humans. And I think we can avoid some of these kind of thornier ethical questions if we think of robots more as animal companions and not human replacements. Which is all to say that the way we kind of frame storytelling around machines is going to be really important in terms of our capacity to imagine machines that can help us, whether it's creatively or to make a buck in construction. All right, so this is not a new idea. Kate Darling who just joined the AI Institute as their kind of principal ethicist. So the idea, the basic idea here just is that like these narratives of replacement of people, I think are less valuable and frankly less realistic than kind of the historical relationship we've had with animals, which is something that is largely subservient but still collaborative, and something that actually has senses that complement our own, so that we can do things that are perhaps more poetic or perhaps more efficient than we would be able to do either on our own as humans or for machines to do on their own. So, better together, the power of collaboration. So I'm not going to talk too much about Boston Dynamics, but where we've landed with Spot. Spot's a kind of long story of like make a cool robot and then not know what to do with it, and try to find product market fit. And I think we've kind of found that in the industrial inspection space, as have some competitors. And it's not. Yes, people go around and do these kinds of rounds and readings. They check for thermal anomalies, for acoustic leaks, the things that the robot is doing. But systematically, this is another layer on top of a factory that kind of infills some of the gaps left by fixed IoT sensing systems to basically have your perpetually running factory so that you're always catching things ahead of time. And that can only be furthered by contemporary AI on top of the robotic capture. So I'm going to get a little bit into like construction robot categories, but it doesn't matter. That there are 100 ways to categorize it, and I'm going to talk about like 0.01% of the interesting things that are happening out there right now, but just things that are kind of on my mind. So I'm in this world of measuring and mapping. If you want to do anything, particularly in a kind of indoor GPS-starved space like a construction site, like you have to map and measure the world first. So there's a lot of interesting things happening with robots that do things, that do actual construction tasks, but if you haven't mapped the world yet and you don't have that kind of spatial database, I think your hands are tied. And I think the question is, how does automating reality capture, which is largely what we've landed on with like the Spot robot in construction, automated scanning, automated photogrammetry, similar things we're seeing in the drone space, strengths to each type of locomotion. But again, like, what is the bigger story there? Again, what can you do if you can scan or perform some type or some combination of reality capture every day without any human labor required? How does that fundamentally change the way you work? It takes scanning as this kind of incidental thing to basically a constant background process, and it allows you to do project management with 3D information. Some people might call it digital twin. I think it's like approaches that family of workflows, but I think that's where you're going. But the issue is where we're at right now, and I think we're going to finally start climbing out of it, is I'm out there selling robots that can do this, and what you're getting is just like way too many point clouds. And you're like, okay, now I have like 1,000 point clouds instead of 10 point clouds, so thanks for the mess. So like, we don't want the data overload. There has to be some justification. Like, why are we, what do we need to feed that requires that level of capture? I attended was anyone at the Drone Deploy conference by any, no? All right, cool, I can say whatever I want about what happened there. So they're doing some really cool things, like, the transformer-based models that have like fundamentally changed language models and ChatGPT, they're kind of mixing natural language interfaces with kind of more advances in computer vision. So you can ask questions of your model, and then the software will like do useful things for you, like reporting and analysis. So, here's a frame from my like video walkthrough I did with a robot, and now do the floor flatness analysis. But they're also showing things like click on any object in that image, and it's like, okay, you clicked on a waste bin. By the way, this is not actually from their software. I couldn't get all the slides of the things they showed, so I'm approximating what they showed. But conceptually, I think this is where we're going. So, this is Brian showing new drone deploy stuff. And they're like, we didn't make that. But this is basically what they were demonstrating. So you have all these computer vision models in the background. And then it just knows what you're trying to do. If you're clicking on this thing, you probably want to like query this thing. And you can, run your cursor over that and ask a different question. I see this and I'm like, okay, now I want to do this. That is valuable. That's incredible. How do I do this? Oh, you're going to need a lot more data than you have. Oh, okay, how do I automate data? And it's like, oh, that like robot Brian's been talking about for 4 years. Now you can kind of understand why you might want to invest in something like that. And not everyone uses 3D. So like a big kind of area like with open space and with Struction Site, which was acquired by Drone Deploy, they're doing these 2D analyses on blueprints. Blueprints are amazing. You can do a lot of things with them. There are people doing this in the 3D space. So there's like the 2D image space, right? Computer vision models to recognize things from pixels. And then there's this like 3D point cloud space where you're trying to do object matching between like segmented point clouds and like, I don't know, BIM elements or anything three-dimensional. That seems to be a bit harder for folks. This is a picture from Avir, which kind of transitioned to a services model a little bit and then got acquired by Hexagon. So I think like in the next couple of years, we'll see some really interesting like three-dimensional object matching stuff from both like Leica Geosystems and Trimble, you know, the big geospatial players. And that'll kind of be like, oh, that makes sense. Like now when I scan, it's semantically recognized in my model. So for those 3D workflows, that'll make sense too. Then there's offsite manufacturing. So I always talk about this because I'm like, before we get into really cool robots that move around a job space, let's talk about what's probably obviously the most valuable thing, which is to stop trying to build on site. So construction as logistics, what does that look like? You know, you've got a factory and you've got a job site, you've got some warehousing in the middle, there are robots for that. You've got, you know, things coming into the warehouse and out of the warehouse on trucks. The trucks can be automated, yada, yada. But like the point of this is if you can move everything that's reasonably, you know, possible to move into industrialized construction methods, what's left to do on site? And that's how I like to frame the use of field robots. Like stop trying to just replicate, again, stop trying to replace the person. Let's try to think about like another level of change. What are the actual affordances of that? So you've got foundation, superstructure, blah, blah, blah. I'm not sure about finishing. Like when I'm in like a prefab hotel and I see the seams in the ceiling, I'm not like mad about it. I'm not, maybe finishing will kind of become like vinyl records. It'll just kind of be like a cool like thing you have that's retro and we won't care about that anymore and you design it into the modular system. And then you also have, once you constrain that, you start to think about what are robots that make sense to make mobile on site, because it's a really hard problem. So you really want to know what you're trying to solve before you start investing in that. But I don't think there's like a useful distinction between the two. I think that, again, like if you're just going on site and you're doing like cutoffs and creating a lot of waste and trying to replicate field labor, like that's just not going to scale. I think you have to combine some kind of constrained set of like modular industrialized construction elements with robotic methodology. And you can take this further upstream. Like you say, the generative design applications are partnered with the architectural manufacturers so that you're running these generative design exercises outside of the BIM, Revit context, so that you're creating like your MEP system, but it's real MEP products. And then when you have a system you like, you can put it into Revit for documentation. But now you also have a much more constrained problem for like object matching and for these you know, recognition models for elements. So it all, again, you know, end to end, think about it holistically, stop trying to do the one-off things. So some interesting projects, just things that have captured my attention lately. So this one is, I think one of the principal researchers is Anya Lawyer. And out of the Institute for Computational Design in Stuttgart, so they've set up this like pavilion, they prefab some timber elements, so they've got this design language, and they're actually retrofitting spider cranes with automation. And I immediately want to think about spider cranes with legs. That's not how it works. Those are outriggers. So they prop up and kind of hydraulically stiffen so that it's in a static spot. But it kind of gets at like a couple interesting things. It gets about mobile manipulation, by manual manipulation. One arm and end effector is holding an element, the other one is attaching an element. But again, it works because there's this known module. And you're doing installation of modules. You're not trying to use a humanoid robot to go out and like plaster and lathe in a building, which, you know, maybe we'll end up there, but it just doesn't seem as exciting to me. This is one from Built Robotics. This is in the solar space. You also think about types of projects that lend themselves to automation. A solar farm is like a very specific set of steps. And again, it's got these prefabricated modules. I mean, granted, they're just, you know, extrusions that are being driven into the ground, but still, that's coming from a model. That's a kind of limited design language. Built Robotics spent a lot of time automating excavators, so they just adapted an excavator to hold all these posts and drive them in. I like this one too because the two things that I'm not super excited about are brick laying robots and 3D printing robots. And this is like the happy medium to me. Because 3D printing robots, it's cool, more concrete in the world. Like, and every time, I don't want to listen, I don't want to get too aggressive up here, but every time you talk to these companies and you question them about the sustainability of their materials, they're like, oh, well, you know, first we're going to prove that the engineering works, and then we're going to build a couple subdivisions and get the proof of concept going. It's like, you don't care. It's just going to be more concrete forever. So, like, we'll see. We'll see. A bit harsh. Is this being recorded? I have friends that work at 3D printing companies. And then the brick stacking theme, just bricks in general, like, why are we still, they're so tiny. They're so tiny. It's like building buildings out of like toothpicks. And they're made for the human hand. So if a robot uses them, why would you have a robot mason using the same bricks? Like, don't do that. Make the bricks bigger. Not, you know, super sexy robotics, a bigger brick. But that's what gets me going. So this is the Hadrian X, fast brick robotics in Perth. So we've cleaned, let's talk about the other thing also. We shouldn't be building anymore. So like, we're killing the earth. So I went to a symposium in Munich, and like every talk was like, a moratorium on building. That's counting down still, right? Yeah, we're good. And like, it was a really refreshing kind of academic, well, it was, you know, bridging academic and industrial concerns. It was the Future of Construction conference in Munich. And so many of the presentations were like, we shouldn't be building buildings anymore. That's the controversy, like if we're going to be serious about ecology. So I wanted to think about demolition and disassembly. So this is another thing that I think with 3D printing, it's the same way I kind of felt about all of the, like if we take like, we'll pick on Stuttgart. So if we like look at all the like, you know, fiber winding and, you know, composites, and like I've perfectly simulated a shell that works in this like, you know, one instance, and obviously it's a technology demonstrator, but if we fetishize that stuff too much, it's over-optimized and it can't be reconfigured or disassembled. So I started to think about, we really need to be investing in robotics for disassembly. This is a Conjet robot. This is like hydro excavation. Has anybody seen this? I go to ConExpo every 3 years, which is like the funnest thing. It's just, you know, every construction machine in the world. And what this does is it actually uses powerful water jets to essentially erode the concrete, but not the rebar. Like it's amazing, right? So it's kind of a concrete eraser. So I'm trying to think about like, how do we disassemble and reconfigure? This is also why the additive manufacturing stuff feels a little bit troublesome to me. So here's some images of how that works. This is that class of things that people call robots, but it's, you know, it's like a remote controlled thing, because it's a demolition robot and you shouldn't be too close to it. But you know what, you can call whatever you want a robot. Like, I'm not gonna judge you. I think everybody should have their own ideas about what a robot is. This was a project I did, I don't know, I think 2018 with Maria Yablanina, and she was at Stuttgart, now she's at Toronto, and Giulio Brunaro, who like went to Silicon Valley. But we were kind of asking some of these questions, and this was just like a robotic tool. If you had, again, you have to have some kind of modular system. If you had modular columns, and you had this kind of infill gantry or tool you could plug into that, and it could wind, well, then we could do all these kind of things talking about performance, because, you know, you could wind to different densities, and it's a metaphor. You're not gonna build your office out of paracord, but you can rewind it. And that was such an exciting idea to me, is like, oh, this is something like a design tool that builds a wall that can also unbuild a wall, and that material is still reusable. Circular design. And this was a good book. I don't know like that this book got like as much love as it deserved. I think this came out kind of in a similar time out of the University of Calgary. It was a collaboration with GXN, which is like the kind of ecological research arm of 3XN. Kristen Forward, actually from MBBJ, was one of the authors of this. And they were actually looking at all of this kind of unused office space, which really, you know, that was prescient. And all of these concrete prefab cast panels on it, and how they could disassemble them, check them for damage, and kind of figure out what was salvageable, what wasn't. They could cut out pieces. There was also a whole section on what you do with the rubble. But you try to not crush the concrete. That's gonna be a lot more expensive than just being able to reuse something. This was something I also saw in Munich. This was out of Lausanne. I don't know if I'm saying that right. Quarantine Fivet, butchering that French-Swiss name, but he's a practitioner and researcher, and he was just doing modular disassembly. That's not even a robot. You could put it on a robot. Anything can be a robot. And they were just talking about like, well, we do have these situations where we have non-structural infill walls, and they might still be concrete, and we're going to disassemble them and just turn them into blocks. Like, just rectangles, baby. But like, they had done some research on the carbon footprint of that, and it was basically the same as if you were using engineered timber, which everybody's, so that's the sustainable thing. And it's like, well, this is just as sustainable. And again, like it's a little bit more expensive to disassemble a building than to destroy it. But this to me was one of the most exciting things I had seen in a while. And it's just chopping a concrete wall into squares. So I'm old now. I've lost my edge. This is where my head's at. Thank you.